So I'm going to be talking about reference angles. Reference angles help you find the different coordinate points on the unit circle so that you don't have to memorize the whole unit circle. You can just memorize the first quadrant. So here it says, let theta be an angle in standard position. Its reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So what all of that means, put into some normal language here, it's an angle in the first quadrant, and we use it to find sine, cosine, and tangent. So that is what a reference angle is. So this is the math definition, and then below it, you have a more basic definition. It's a first quadrant angle that you use to help you find any of the other sine, cosine, tangent. You can even find the reciprocal functions in other quadrants. So I have this website right here that we are going to go to. So here we have this demonstration of what a reference angle is. So here, the black arrow is representing our angle, and then the blue arrow is the reference angle. So if I were to spin this around, 151 degrees has a reference angle of 29 degrees. So 29 degrees is between 0 and 90. It is a angle in the first quadrant. If we go to the third quadrant, 234 degrees has a reference angle of 54. If we go further, so if we go further down here to the fourth quadrant, 310 degrees has a reference angle of 50 degrees. So we can also do multiple circles around. So here, 1,055 degrees has a reference angle of 25. This is kind of a cool website. I have it in the PowerPoint, and it shows you all of the different reference angles. So now going back to PowerPoint, to find a reference angle, the step one is to unwind the angle. So what I mean by that is find a value that lies between 0 and 360. So if your reference angle is 1,055, subtract 360 until you get an angle that's between 0 and 360. And then from there, sketch the angle to see what quadrant it's in. You don't have to sketch it if you can just go off of the quadrant rules, and then you find the reference angle based on these rules below. So for quadrant 1, that's always the same as whatever your angle is, same for radians. In quadrant 2, it's 180 minus the angle. In radians, that would be pi minus the angle. So this is not 182 theta, it's 180 minus theta. For quadrant 3, it's the angle minus 180, or the angle minus pi in radians. And then for quadrant 4, it's 360 minus the angle, or 2 pi minus the angle in radians. So as examples, I might ask you to find the reference angle for different given angles. So for this first one, it says theta is 300. So our first step is to figure out what quadrant it's in. 300 is in Q4. And the rule for quadrant 4, if we're in degrees, is 360 minus the angle. So those rules, once again, are right from this chart. So 360 minus the angle when we're in degrees, quadrant 4. So that would mean our reference angle is 60 degrees. And then you're done. So for example, at 300, that will have the same point as 60 degrees, which is different, negative and positive. So that's the purpose of a reference angle. For B, so 2.3 radians. 2.3 radians is in quadrant 3, quadrant 2. So 2.3 radians is in quadrant 2. So in quadrant 2, the rule in radians is pi minus the angle. So we want to do pi minus 2.3. So when we plug in pi minus 2.3 into our calculator, the answer that we get is 0.84 radians, and that would be our reference angle. For the last one, negative 135. So that is not between 0 and 360. So the first thing we have to do is add 360 degrees. We get 225. So now this is not our reference angle, but this is what we're going to use to find the reference angle. So 225, that is in quadrant 4. So the rule in quadrant 4 is 360 minus quadrant 3. Sorry. This should be quadrant 3. So 225 is in quadrant 3. So the rule for quadrant 3 is angle minus 180. I knew something didn't look right there. So 225 minus 180. And we get 45 degrees as our reference angle. So you can use reference angles to help you find points on the unit circle, makes it so you don't have to memorize the unit circle, and that is how you find them.